Hello guys. I installed the AURIX Developer Studio. I'm using this version. It is an Eclipse-based IDE. Because of this, I'm able to install the Parasoft C, C++ test as a plugin into this IDE. We can see the Parasoft menu here. If if this menu is not available, go to Windows Perspective and switch to the Parasoft Perspective to see the Parasoft menu here. This example project is generated using this IDE. It has been generated for the AURIX TC397 example template project. I noticed these 6 main entry points in the generated code. First, go to Parasoft menu, Preferences, and enable High Verbosity Console. You will notice here that I switched to the Tricore GCC compiler. The other variant would be the tasking. In this demo, I will be using the Tricore GCC compiler. Using this compiler, first let me try to build the project. And this would be the build firmware. Now the configuration of the Parasoft plugin and the project happens in this menu here. Click this tab node, right click, go to properties, expand the Parasoft menu here, and go to the build settings of Parasoft. Because I'm using the Tricore GCC compiler in the IDE, I have to match it with the appropriate compiler family that Parasoft plugin has is available for selection. So you can drop down here and we can see the available family that matches the existing active compiler. As there is a compiler family for the GCC for Tricore, this one. So I have to select this. And all of these fields will be auto-populated. So far, this is the only change that I did. I also unchecked this synchronize with project settings. So let me cancel. So after making those changes to match the compiler family, now let us try to do a static analysis. The generated code is consisting of many C codes. So if I select the top node here, I would be implying to do a static analysis of all of the generated C codes. If you select only some files like that, or select one file, then you'd only be doing static analysis for the selected file. So for now, let me just select at the top node here to imply the selection of all files, all translation units, that mean all files that ends with .c, then right click. You should see a Parasoft menu here, test using, built in, and I will choose to do compliance static analysis, and I will choose automotive pack, and I'll choose this ninth item here for Mesra C 2023 sets of rules. I will select this, and we can switch to the console tab to see the static analysis in action. As you remember, we enabled high verbosity settings in the Parasoft preferences. So we should be able to see more information while static analysis is running. You can see the percentage here, it's 45%. So let us give it some time to complete. And static analysis has completed. We can switch back to the tab here, and we can see this red report here, 17,323 tasks reported. We can expand there, and this would be the findings of a static analysis run using Mesra 2023. Now, we will not go over each one of these findings, but that is how you do static analysis after you set the matching compiler family in the Parasoft C++ build settings. All right. So the next thing we need to do here or to try is unit testing. For unit testing, the same procedure, we can select the top node here and auto-generate unit test case. However, it is often prudent, and we have to be start small, like selecting only a few files here, and then right click, Parasoft, test using built-in unit testing, generate unit test. So let me select this. So let's switch to the console. Oh, so the unit test cases have been auto-generated for the selected files. Now, I am I have to explain that I have to select a few files. In certain situations or in most embedded systems, many functions contain an infinite loop, like a while one, and it does everything. In cases like that, we have to be careful to first avoid those functions, but there is a way for Parasoft to break out from those infinite loops using a timeout, but I will not be discussing that topic in this session. So we have to start first with simple functions because it is the architecture is what we are trying to explore here if it is uh, the level of support for unit testing. So these cases have been auto-generated under the test folder. To view these auto-generated test cases, since we are in the Parasoft perspective, there is a test case explorer. I will click that now here, in case the test case explorer is not visible, you can drop click Parasoft, show view, and then select test case explorer. Now that the test case explorer is selected, expand this, and we should see the generated test cases here. All right. So now that these cases have been generated, let's try to um, build an instrumented firmware for these cases. Right click, Parasoft, test using, built in, and there is a dedicated test configuration for Tricore under embedded systems and Altium, run Altium uh, tasking CTC test. So let me run this and let me switch to the console tab. All right, so we can see here at the logs that since there's no attached board right now, so no coverage log have been generated. But if we uh, check here and we can see that this path here has built a cross-compiled firmware that is supposed to be copied into the MCU, execute there, and the result of that execution is returned back to the laptop, and they are represented as these two files here, tlog for tslog and coverage log clog for coverage log. Like I said, since there's no attached board, so we can see that uh, we have not generated a coverage report here, and all of these are in red. So if we expand the coverage data, is everything is 0% as nothing has executed, but the firmware is built here. This one, we can go to the file system and examine that this binary is of tri-core binary format. So the detail of this execution, we can go back to the Parasoft test configuration, embedded systems, Altium, tasking, execution, default test configuration. If we intend to modify or examine them, we need to duplicate them. So this is the test configuration that we just executed. In order to view the internal of this configuration, let's try to duplicate. In the duplicated copy, let's examine the XML file. And this would be the needed configuration to flush the firmware to the microcontroller and return back the test results to the laptop. Again, this XML file can be modified to fine-tune the embedded workflow. Um, to explain my point here, let us take, for example, uh, embedded system run test for targets with SSH. So let me duplicate this. So the point that I was trying to say is that, for example, in this configuration run test for targets with SSH, and this would be the selectable detail for the test run. There is a destination folder of the target. There is a username to SSH2, and the full detail of this configuration can be controlled inside this XML file. So let me expand this. So the the IP address that you specified is assigned to the SSH target key, and right below here we can see that execution of the firmware is made possible through the XML in an automated fashion by first copying the cross-compiled firmware into the target using the scp command, see, and then executing it using ssh command and execute running the cross-compiled firmware, and then copying back the test results log on coverage log, the test log and coverage log back to the laptop here, wherein the coverage report is generated in the IDE. In the same way, this is what is we are trying to set up in case of serial communication arrangement between the laptop and the microcontroller. Without a hardware, this is it for now. In my next video, I will show you an actual serial communication that is uh, returning back the test results and coverage data from the firmware, from the MCU to the laptop, and displaying the gathered code coverage.